What up, Vafi? What up, Suyash? All right, let's get ready here. All right, let's get our RFC spec up. We're gonna get to write that the answer data today, where it has the compression built in. Should be pretty cool. Yeah, this part. This is the compression part. So we had the question section format. Tmugs, yep. Just take some time. Oh, it's coming along well. We can decode the header and the questions now. If we run this, you'll see that given this DNS question right here, if I could scroll up, which is basically example.com, and it's asking for an A record, we're able to decode, encode, and then validate that the input is equal to the round trip of encoding and decoding. So let me pop this open here. Decoded is Q name. This is example, right, in ASCII characters. This is COM, C-O-M. This is going to be an A record. This is in, and then when we re-encode it, it goes right back to the correct UINT 8-byte array. I would look at the README mentalist for, let's see here. HTTP platform, effect, GitHub. Not Ronnie. This README right here is going to be the best place to start. And then there are some good YouTube videos by Lucas. Yeah. this guy right here. This guy has a bunch of really good YouTube videos on his channel. When days are not good, other things start to fall apart. The only person I had betrayed me, and whoops, I got a bad breakup. Anything to cope up this? Yeah, I do have advice for that. Basically, just, you know, I don't know. It's tough. It's hard. Just keep your head up and keep going forward. Don't bottle stuff up. Talk to people. Things will get better. The hardest part of it is probably uncertainty, and the more uncertainty you can handle, the better things are going to feel quicker. All right. So we need to get the answer section. The answer authority and additional instructions all share the same format. That's nice. A variable number of resource records, where the number of records is specified in the corresponding count field in the heading. Count, 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 count. Suyash, I wouldn't say that I have a perfect 10 score in every aspect. I went through a divorce in my mid-20s. I understand better than most that kind of betrayal. My ex had an affair, or my ex-wife had an affair, so I get it. You just gotta stay positive and keep knocking shit out and moving forward. Does the decoded version need a specific format? Just thought that Q type 1 isn't that clear. Yeah, I haven't decided if I'm going to decode to more semantic meaning yet, Boffy, or just keep it as the spec and then at a higher up level take the decoded values and translate it into things like A and NS or things like that. We'll probably get to that later this week. But we're in a place where we at least have access to the data in an easy way. We don't have to parse it anymore. Good morning, Morgan. My sister is in chat. And Davey? Good God. Everybody's here. Good morning, everybody. Oh yeah, I also vibe coded a sweet tool this weekend. Let me see if I can get it pulled. Stow doctor when do you Satellite. Okay, cool. All right, so we got dot working. So I should be able to do like dot update. This is the nicest tool ever. It's still going to this day. Yo, backwards one night Cedar Crest. Yeah. I just need dates, Morgan. Of course I'm helping. Okay, so we need to go back over to this project and we need to add our resource record format. Let's jump up top. Oh, this is not the right file. Or actually, we should write tests for the hell is this? Let's see if we can get Claude Code to write tests for decoding the question. Describe question. And then we'll do Claude init. Thank you, Vishal. Oh, we need to get you split right. Twit. Isn't it twit? What is the Isn't Twit the thing we were using to run chat? Am I crazy? Config.twit. Brew install twit. Is this because I don't have... What happened to Twit, chat? I lost the Rust. I don't know why. What the heck? Do we have Rust installed? Or cargo? How did I lose this stuff, cargo? Yeah, I think I still have the... I just saw that I had the /twit .config twit right there. Right? Like this is, yeah. Cargo just became uninstalled, I think. Rust up. I think I just lost my Rust up stuff. All right, we have that. All right, there we go. That was weird. Hey, dude, it really has been, hasn't it? Listen, more people talking about it is good. Even if just a handful of the people that are upset about it cause a handful of people to try it, I think that's a good thing. This was the one. This... It's so funny that, like, This tweet is for people writing and learning Effect, not people interested in Effect. And like, this is the one that got attention, when really this is the tweet that I would have rathered more people see right here. This kid this kid picked a weird hill to die on and argue about. The potential time wasted if they desync is enough for me to ban JS docs in our code base. Can you imagine being upset enough about this part of the snippet here to ban JS docs from your code base? I don't even write these. I have an LLM script that goes through and adds JS docs and makes sure they're in sync with the code. Like, give me a fucking break, dude. And I was like, to be honest, I don't really care enough to die on this hill. I find hover docs nice, but if someone felt strong enough that they wanted to ban it, I'm far past that point in my career to care or fight that kind of fight. Like, I just don't care about code style anymore. Like, I'm never gonna argue, about using a for loop over using for each or map or using semicolons or quotes. Like, I just do not give a shit at all. And like, people got upset about me using a namespace in the example. Which one? What's up, John? People got upset that I used a namespace in this, and like, a namespace, like, yeah, don't use namespaces in your front-end code. Goes without saying. They don't tree shake, although most people don't have setups that tree shake anyways, but a namespace is literally just a JavaScript object at runtime, right? Like, these become keys on an object, and the nice thing about a namespace is that you can export types on them. So like, it just makes sense. And I understand it's like a not well received feature, and I don't know, whatever. I don't give a shit. If someone's upset about this at my, like, if I'm on a team that's upset about this, I'm not going to use it. Like, I will never die on the hill of using namespaces. Like, I do not give a shit that much. What's the type of bit and nibble in your DNS header post? Good timing. I can show you. They're defined with effect schema. Let me get out of here. Is it in here? So a nibble is a number that is between 0 and 15. It represents a 4-bit unsigned integer. And then a bit is just a literal number, 0 or 1. This repo is also on my GitHub, John, if you want to go reference it. All right, I want to see if Cloud Code can write add tests for encoding, add fast check tests with effect for encoding and decoding questions in at RFC. No, this, I'm working on trying to get this. I'd like to convert this into a DNS resolver in Effect's platform package. And the long story short is the reason we're writing parsing from the ground up is because Node's DNS library just has like a bunch of footguns and isn't as flexible as I want it to be. So that's why we are working on writing this. And I mean, I do want it for work, to be honest. That's the underlying thing is I want a nice effect DNS resolver to use at work, but I would also like to get it into the the effect platform package. Yeah, no problem, John. Let me know if you have any questions. Claude Code is actually really dope, chat. I got a subscription through work for the Mac subscription, and I've been loving it. Nice. We'll go and audit these these tests, or Jesus. Like, it's really good. It's really good at effect. I think people are, I mean, I've made this argument a bunch this weekend, but like Claude Code and Claude Sonnet 4 are really good at effect once there's some code written. All right, let's see the actual code that was written here. I'll make sure that oh yeah, I wanted to fix this. Get rid of that. He's always confusing Gleam with Rust. That's funny. Well, this is at least open source, so this isn't the best example. Well, this would actually be a good example for AI to look at, or for schema, because AI is really bad at schema. All right, here's the test. All right, so we made arbitraries. This is good. Let's see, we want that, and then that. Oh wait, fuck it. All right, that looks good. I'm pretty sure QType. Let's go check the spec for QType. I don't think QType. A 2-octet code. The values for this include all codes valid for the type field, which is going to be. Where do they outline the type field? Type. All right, we'll do. Let's go back to Claude and say, these update our arb QType to reflect this from RFC-1035. Not 1034. It's RFC-1035. Sorry. And then QType. I mean, it at least linked to almost the right place. It actually might have linked to a proper place. No, it didn't. It got close. Yeah, this thing is going to town. Great. All right, let's go make sure this thing didn't go too rogue here. All right, let's see here. It added, we don't need you. You don't need a bunch of you. DNS type. We can take this and we can probably convert it to a schema. Not supported. Oh, you son of a bitch. Whatever, that's fine for now. I think I prefer a single. I don't know. I would play with it and see what feels best. To you. Is this used anywhere else in here? Okay, cool. It's not. That means in here, we have some type errors. Let's make sure we can run the LSP in here. We'll add a type check, which will be just TSC. And that should work. If we do bun type check. Yeah. Okay. So then we should be able to do clog continue, and we can do a slash compact. I also want to set the model. I think it defaults to using Opus, which I don't want to do. Sonnet. Fix the type errors. You can run bun run type check. Did that work? Oh, that made it as one. I'm interested to see how this fixes this. I think I might let Claude run on a code base at work today for upgrading TypeScript from TypeScript 6 or TypeScript 5.6 to 5.8. There was changes in the typed arrays types. And it's caused, I mean, we have like over 1,000 type errors in our code base at work because of that change. I might just let it run. No, this is Claude Code. What? Sure, I don't care in test, that's fine. I don't know why I changed it to expected. Yeah, there you go. Make sure test pass. Idiot. Nice. So the cool thing about our test here, chat, is we talked about this last week. We're using fast check, which comes bundled with effect. But like even if you're not using effect, you should use fast check because it generates a ton. It runs like 100 different tests per unit test for you. So like here, this will run 100 times and it will generate a random uint array 100 times and test tons of variations of it. So we decode a uint8 array to a question. Great, that looks good. That looks good. That looks good. Yep, that looks good. That looks like a good test. Decoded question has valid queue name structure. Yep. Nice, that's a good test. This is a good test. Dude, that's so awesome. This is so sick, chat. It handles a single label domain. Nice. And if we run this ourselves, let's jump out of Claude Code here, and we run bun run test. Nice. Noise. Let's do like npx tsx. Not tsx. npm run test. What about pn run test? There should be a way to configure. I want to go look at the fast check docs quick. All right, so technically you see that property there, that fc.configure global runs. I'm curious if we do that, if we still get passing tests here. Let's say got configure global. And actually I want to do a let's do like a console.log of what the current read configure global. I'm interested in what that will end up being. It doesn't have a global. See that logged out an empty object there? Although it's possible that, let's say fc.configure global, and we'll say, what is this? String any. We'll just say this is going to be console.log. I just want to see if we can get some other output. Num runs. 100 by default. Like we could set this to do 1,000 runs per test. There's 1. There's 2. There's 4. Hell yeah.
Speaks the gospel of the
what
camel.
Up, Mr. Love Wizard?
I speak the gospel of the dunes.
Thank you for 13 months.
The
That's
sand
wild.
is in my veins. Come ride a camel with me.
Cool.
Today.
So this works pretty well. Wonder if what verbose looks like. I don't know what this value is supposed to be. I'm about to be drowning in peppers. Such a good problem to have. wonder if we can do, I've noticed in the past that bun sometimes, bun run, bun vitest, is that what I want? Bun run bun vitest. Bun run test. All right. Whatever, that doesn't matter. All right, our tests are working. Let's write our new encoding. Let's actually commit here and say we have, did I get rid of this? And we can get rid of some of these comments. These are actually probably fine. Bun test, because it doesn't have, vitest has, is wrapped by effect and gives me like special APIs for testing effects like itEffect.prop, bundles, fast check, tests, git push. And I mean, I can try bun run -- bun test. Yeah, it doesn't do anything. All right, let's switch back over here, and now let's start writing the, we want RFC-1035, and we need the record. Where are you? Question second message compression, resource record format. Here we go. This is what we want. Come down here. Then we can come in here, do this, and we'll do this. That's not what we wanted. I never remember what is the NVIM keybinds for multi-line comments? GCC. What am I thought in the newer versions of NeoVim, it's built in now, and I got rid of that. Yeah, I don't have comment out NVim anymore, which means what just happened? Okay, I just want to look at the help docs, please. That's what I thought, but it like, I thought it was context aware. Maybe it's not. We can just come in here and we can do, we can say AI convert this to multi-line JS doc comment. take that, yeah. And we can get rid of, yeah, good. This part's going to be so fun because it has compression. I think I might split out this file, start splitting out stuff to we can keep working in here, it's fine. Const question, so we'll do this. And we'll come down here and we'll say const, this is going to be a resource record. Record equals a schema dot struct, and this is going to have a name, which is I think we have a type for name. Yeah, we do. We have type 2 octets containing one of the RR type codes. So was that 16-bit? uint 16. And then we have class, which will be a uint 16. TTL is our 32-bit. Pretty sure we have a int 32. Yeah. Int 32 RD length is going to be a uint 16.
Functions describe the
It's interesting that in the same spec they say 2 octets and then they say an unsigned 16-bit integer, where isn't 2 octets or octets Monday morning. I'm out, thought this was a family stream. Sorry, wizard. After writing structs in Go, then going back to some Python for work has made me question life. RIP. What up, Fiskin Hero? Octitties, yeah. Octitties. But isn't 2 octets? I feel like is 2 octets the same as a 16-bit integer? Am I crazy? What up, Kolkus? Why would they use... That's such a confusing way to write. Like, 2 octets, then down here an unsigned 16-bit. I think, hold on, let's go make sure. So that says 32-bit. There is a signed 32-bit integer somewhere. I want to make sure I didn't screw this up somewhere. R data. Serial is an unsigned 32. All resource records have the same top level format. Resource record, a 32-bit signed integer. You see this? 32-bit signed integer in section 3.2.1. And if we go down to section 4.ttl, a 32-bit unsigned integer for a resource record format. Which is it? Bro, you can't be writing a internet spec and messing that up. RFC-1035 has conflicting information on the size of a resource records TTL. One section says it is a 32-bit signed integer, and another section says it is a 32-bit unsigned integer. Which is correct? Thanks, Maxwell. I mean, right now, it's not very library-like. We're just like brute forcing through parsing and encoding and decoding. Dude, my shirt is all bunched up. But we'll go through and clean it up once we have like the whole spec working. That's what I'm saying. Dude, I know. I want to mute my one thread so bad. This one right here, I did not intend to get as much attention as it did. Like, this tweet is for people who are writing effect, right? This is for people who have bought it. This is like, what is the best way that I think to manage like dependency injection and layers and tags, right? Like, this is not, I should have thought about this, but like, this code snippet is going to look weird and foreign to people who have never seen effect. Like, this one I don't think's bad. Like, fucking grow up if you can't read this. This is the one that I wish would have got attention, which is starting to a little bit more, and I've tried to be posting it everywhere I can, but like, God, so annoying. I mean, the likes to pins bookmarks are pretty good, so I'll take that as a good sign, but people are just super annoying about some of this. I mean, honestly, I don't really have too much of a problem with this take. Like, Nest.js and CQRS, like, is better than the majority of TypeScript. I don't like writing Nest, but it has some similar properties to Effect that can at least help you and your team write better TypeScript code. That is not true at all, bud. All press is good press. Yeah. Yeah, I think my hot take is if you're upset about the aesthetics of code, you just need to grow the fuck up. That's my hot take. Especially if it's using, like, TypeScript and regular features of TypeScript. Effect is like kind of like a standard library for TypeScript. It's got things like observability, resource management, scheduling, state management, batching, caching, concurrency control, streaming, errors as types, platform agnostic interfaces, so you can write once and run on Node, Deno, Bun, Cloudflare workers. I use it for everything now. It has really good dependency injection. The dependency injection is pretty novel and looks different than a lot of things, so people have a hesitance or have a your first time seeing Effect, it looks weird. I agree too, Maxwell. I just like need to mute. That thread really. Yeah, like if you can't read this code and figure out what's going on here, like I can't help you, right? Like I can't help you if you can't understand this. If you're not a junior, like an actual, like really junior dev, if you write TypeScript every day and you can't figure out what's going on right here, stop writing TypeScript is my take. You have to figure out what effect.gen does, which reading the docs will get you to the point that this is basically like just using the async keyword. This is like using the await keyword. Boom, done. Yeah, also true, Maxwell. After my wedding's out of the way, I'm going to start working on some Effect conference talks for going into 2026 to try to hit some of the bigger TypeScript, JavaScript web conferences. I just gotta, I can't take on starting to write talks until after my wedding. Otherwise, I know I will stretch myself thin. I had to like say no to a bunch of stuff over the past couple months because I was like burning myself out. All right. Yeah. I don't want this one. Both descriptions appear in RFC-1035, but the latter DNS clarification unsigned. Do we need to be looking at RFC 2181? Clarification. They had to issue a clarification. Yeah, the definition of value is appropriate to the TTL field, and it is hereby specified that a TTL value is an unsigned number with a minimum value of 0 and a maximum value LOL. And this is going to go from 0 to now I know how the Ladybird team feels trying to implement the browser specs every day. Is this really playing Hollywood Undead right now? I don't even know how to like address this. 32-bit unsigned int. Let's grab you. I actually want to use the same website, so we should be able to go to whatever. We'll update the links to be consistent later. 32-bit unsigned integer. This will probably cause our test to fail, I bet. Maybe not. Oh, because we just updated the schema, and we're using the schema for an arbitrary. Ha! Yeah, no, you're right, Fiskin. They wrote the spec poorly. We don't even need TTL. That's just an alias. That doesn't even need to... There we go. Make sure that doesn't merge down into it. I'm gone. I think your uint 32 range is wrong. It should be 2 to 31, but it's using... int 32 range. Unsigned int 32 range. Yeah, you're right. Thank you. That is not what we wanted at all, but we'll take it. The wireless guys go, yeah, I haven't interacted with him until this weekend, Sally. I want to reach out and talk with that person. I feel like it's fun to be part of a developing ecosystem like that. I could see it take off. Yeah, I think I mean, look at what Johannes Schickling did with Live Store, right? Like Live Store is hopefully going to grow into being like the de facto standard for like local first and like data sync engines, and like that exposes a promise-based API and is async and is built all with effect under the covers. I think there will be a lot of stuff like that. What's up?
Do you have anything to suggest?
I'll take a Americano. Iced Americano. Thanks.
Welcome. It smells nice in here.
I have the candle on the warmer.
You do this and then there's no wick.
I know, I've messed that one up too. You could probably get tweezers and grab the wick out.
Yeah, but then the tweezers are drenched in wax.
Okay, well, you can wax it. That's such an easy problem to fix.
Or you just only use these candles for...
I know.
Candle.
I messed that one up. I did not intend to ruin that one.
How dare you? I know. I spent my hard-earned money on that candle, and then you said it's actually mine.
Well, you got a bunch of you got a nice candle or two for your bridal shower.
I got one. But
Well,
yes,
we'll
that's
get more.
my candle. Don't touch it.
Okay, I won't.
That's mine.
All right, let's run tests again. Make sure that's good. Okay, that still is good. I want to make sure that there are no inconsistencies in the tests, and that we are, if we're generating any TTLs in here, okay, I think we're actually good. Yeah, okay, we're good there. All right, let's go back down to our resource record. Down here. What is the name again? A name is a array of uint 32s with a max length of 255 bytes. Okay. All right, I actually want to tweet. The definition of values of purpose is C13 is not as clear as it should be with respect to how many significant other values. It is hereby specified that it is an unsigned number with a minimum value and a maximum value. Is this wrong too? Did they screw up again in their spec? Did they double fuck up here? Two to the 31st minus 1. No. I guess that is... The spec says a 31-bit integer with the most significant bit as a 0, I guess. Implementations are always free to place an upper bound on any TTL received and treat any larger values if they were that upper bound. The TTL specifies a maximum time to live, not a mandatory time to live. So it's a 31-bit number, 31-bit unsigned int range. And then that should give us the two, yeah, the number we had before. Okay. All right. So this is actually a uint 31. (31-bit) unsigned integer. That is when you forgot to peer review RFC-1035 before and said DNS details are both 32-bit, 32-bit unsigned. No, I know how I want to do this. B, software eng. When was RFC 1035 written? 1987. The software eng in 1987. Writing RFC 1035. DNS. Right in section 2. What are the sections? We're gonna get this tweet right here. The first section where we see TTL is 2.3.4. Right in section 2.3.4 that TTL is a 32-bit signed integer. Right in section 4. Right in 3.2.1. We can copy that. And then we can do this. Four dot 1.3. Right in section, what did, dude, I just forgot. 4.1.3, 4.1.3. Right in section 4.1.3, that is a 32-bit unsigned integer. Publish spec. Realize you messed up. Publish. Oh, dude. Be a dev. And then the correction is in RFC 2181, right? RFC editor 2181. Publish RFC 2181. What can we say here? How much do we have to get rid of? We will make this fit in a single tweet. What would be the right emoji for this? Melt? Do you think melt's a good one? Oh, dude, that's because it's more than... Two dot three. Hold on. 2.3.4. Three dot two dot one. 3.2.1. 3.2.1. We're gonna make this work. For DNS. We can get rid of that. We can get rid of that. We can get rid of that. I need... Oh, I need 2 characters. Be a dev in 1987. Writing. Realize, publish. Oh, we're so close. Here we go. We'll do that. Be a dev in 1987 writing RFC-1035 for DNS. Section 2.3.4, TTL is a 32-bit signed in. Section 3.2.1, TTL is a 32-bit signed in. Sections 4.1 to 3, TTL is a publish RFC. Realize mistake. Publish RFC 2. And let's lowercase this. We got some. There we go. That was a lot of work to make that fit. Okay. Great. We got that tweet out of the way. I didn't know that RFC 2181 was a thing, and I find that actually pretty hilarious. Author's addresses. That's bold. I wonder if this has the author down here. It does not. What is Maca Petrus? Paul Maca Petrus. He's the guy. What a legend, dude. This guy is a legend. Oh, that's a good look, Fiskin Hero. I don't know how I would do that because the Twitter API is kind of dog water. He developed the first SMTP, proposed the DNS, wrote the first DNS implement called Jeeves. Dude, this guy was a badass. He worked for Cisco. Is he still alive? Yeah, he's still alive. Dude, I would love to talk with this guy. I wonder if he's given any... Dude, I'm gonna name... I have to build a new service at work in the next coming weeks for managing Vercel DNS. I'm gonna name the microservice Maca Petrus. From Barcelona, dude, or is he from Barcelona? No, he's from the United States. Yeah. I don't know what RFC. Let's go look what RFC 4034 is. $40.34. Oh, this is DNSSEC. Yeah, we'll have to get around to doing DNSSEC at some point.
Do you know if you have a charging block at all?
Block? If I do, it's in one of those drawers.
That's what I figured. Perfect. Sorry. Let me fix that.
Okay. I'm gonna skip this song unless somebody requested it.
Ooh.
Why you? Okay, Kraut did it. Kraut just changed the vibes on us. So we got UN31. Okay, so let's write our const. We want to go up here and we get, this should be pretty easy to decode. Oh, I say this every time Kraut plays this, that I'm like, oh, is this from, oh, what is the game? I can't think of the game. Whatever, it doesn't matter. Not Diablo, it's a game like Diablo. Now this is gonna drive me crazy. New chat. Game like Diablo on Steam, but not Diablo. Not Path of Exile. Grim Dawn. Grim Dawn. I love Grim Dawn. I spent a lot of time playing Grim Dawn. Oh, really? Kraut, can you link me an article on that? Dude, I just there's so many games I want to play that I love Grim Dawn, dude. This will be resource record from uint array, and in here let's just go ahead and do this. Actually, we can go up 7 over to here, delete in there, and we'll do throw to do. Same thing in here, delete in that, and we're gonna do throw to do. I'm so excited to write the compression. All right, so the first thing we need is 31-bit. A name. So we already know how to. So what is the max size of 2 octets, 31-bit? Fangs of Astracharn? A new mastery? Oh my goodness. Ascendant mode? Oh, dude, I'm gonna have to read through this. Let me add this to my read later. All right, so back to resource records. We want to go to section 4.1.3, TCP. .1.3. I feel like it's bad that I'm starting to memorize these sections. All right, so we might have to write our compression first. What up, Zen? Oh, dude, no worries, Fiskin. Let me bookmark that too. And we'll see if we can hack it at some point. All right, before we get into this, I'm going to run to the bathroom and go let my dogs out, and we will be right back. And then we'll, I think we should probably write the compression first. So the way the compression works, This is going to be super cool. We figured this out last week, is that in the name section of a resource record, you have like name, right? And this ends up looking like, if you had like example.com, right? It ends up looking like, I think we have an example in our tests down at the bottom. Yeah, right here. So this is what like a name section looks, let me give a better example. Right here, this name section where it says, all right, so the first byte is saying, hey, the next label in the name, which labels are like basically subdomains and the apex and the TLD, the parts of a domain. So this is saying, hey, the next label is going to be 7 bytes in length. So we go 7 bytes, and if you were to transform these bytes to ASCII, it would be example. And then we hit the next length byte, and it says, okay, the next label length is 3. So we read the next 3 bytes, and if that were ASCII, it'd be com. So what's really clever is they came up with this compression schema where, like, let's say you have multiple domain names in a message. So let's say you have f.isi.arpa, foo.f.isa.arpa, and arpa as like the root or apex. So in this message, this is the length bit. It's saying, hey, read 1 byte, and that is the next label. So we read 1 byte, it's F, right? So that matches that. Then we hit the next length byte. This is saying, hey, the next label is 3 bytes. So we read 1, 2, 3. That's ISI, right? We hit the next length byte. It says, hey, the next label is 4 bytes. A, R, P, A, and then we hit the null terminator. So then we just read F, we read this, right? So we move on to the next name. It says, hey, this is going to be length 3, right? So read 3 bytes, and that'll be the next label. F-O-O. There's our foo, right? Then we hit this 2-bit number here. This 1-1, it says, hey, this is actually a pointer back to another place in memory. And it says, hey, you're going to go to index 20 and start reading from there. So we have FOO, and it says, hey, go back to index 20 in this byte array. So we go back to 20, right? And then we say, oh, here's a length. We read F, that, and then you read back this. So it's like pointing, it's basically like this little recursive loop that goes back and forth. It's really, really clever. So we're going to implement that here in just a minute. I'm going to go let these pups out and run in the bathroom, and we'll be back. Okay, we're back. Let's see here. Let's write this compression. Compress and decompress a name. So let's actually come in here and we'll start down here and we'll say function we should probably start with decompress. Decompress name. And this is going to take a name, which is a uint8 array of length 255, I believe. Go look at the definition of that. Yeah. I want to add the description. Let's say uint array containing 255 octets or less. Now I should be able to see that when I hover dock it. Yeah, there we go. All right. Let's say this is going to be an interface too. I don't want to see that type. Schema.type. What is this subset about? There we go, like that. Yeah. All right, so we got a name, and we can see that here now. Uint array, yep. And when we decompress, we're going to read. We probably want to read it to code points, right? Because that's what we do. This comes back to the question that Vafi asked at the beginning of the stream. Is currently we're decoding into oh, where did this come from? That's weird. It should be mutable. Oh, that's interesting. It should. Qname dot thinks it's a. Why does immutable work? It's like not what I want though. I really don't want to wrap it immutable. Whatever, we'll just keep it how it was. Do we want to convert to ASCII? That's the question. I don't think yet. And we should keep it as a uint8. like keep it in bytes. All right, yeah, we'll keep it as bytes. So let's say this will be, I think it's labels, right? It's not even really, this is going to be a uint8 array. Uint8 array. And we'll say this is going to be name. And this is really a mutable name. And then we'll say, I wonder if we should use recursion here. So if we do recursion, I don't know if we want to do recursion. We'll start with just a for loop. Let index equals 0. Index is less than uint, less than or equal to uint8 array dot length index plus plus. And as we read in here, we have a mechanism already. Might be worth splitting this out into we do this yeah, actually this is smart. We should use just a while loop. Oh, and Justine's calling me. Yeah, what's up?
Hey, can you do me a favor real quick?
What do you need?
Will you look and see if there are Beats headphones on the 900
Beats? Headphones? What color? Like buds or cover the ears? There's a box, hold on. Yeah, right here. Okay. Right here. Okay, sounds good. Bye. All right, we're back. Queue name, label. Is that all of it? Yeah, that is what we want. Okay, cool. So let's come in here and we'll paste this as reference. Let's just throw for now. I don't know how we're going to do this. We can probably just make this an effect. Throw, yank around that, and we'll put that there. We'll say to do convert to error. Same thing down here. Throw. Okay. All right, so when we're decompressing, at offset, we need to check to see this double one, where they define this somewhere in the spec. Here we go, a pointer. So we should be able to const is pointer is going to equal something like this, right? We can use we'll fix this in a second, but just to get the logic right, it would be like data view dot get. It's not even a uint 8. We would do uint 8 array dot do we have anything in here? Might be slight subarray. Gets a new uint 8 array view. Begin. And that takes the begin, which is going to be offset. And then the end is going to be offset +1. This doesn't even need to be an immediately invoked function expression. Whoops. And then the real logic here is, let's wrap this in a parentheses, and we want to bit shift it 6. And we want to apply a bit mask of 0x would be like x be 2. 2 in hex. 0x2. Is that really it? Is that not the function I want? Oh, do I need a date? No, not a data view. How do I get this? So I have a uint 8 array. Let's back this up here. This is like const next 2 bits. Right? That's what we really want. and subarray gets a new uint array view of the array buffer stored for this array, referencing the elements at begin. It's not even like we need the offset, right? We're at the offset and it's a byte. We're not looking at a bit. Right. Hold on. Hodl chat. I'm mixing bits and bytes. We can use our data view dot get our unsigned int at the current offset. Does this take the flag for endianness? No. And that is going to give us that, and we need to bit shift because it's going to look like, it's really going to look like 1 1, and then we're going to have 1 2 3 4 5 6, right? And then we need to bit shift it 6. Difference between and JS. Signed right shift, unsigned. So we want to do an unsigned shift. So this should give us a number, right? Yeah. I think I had it right. We go like that, and then we bit shift it 6, and we mask it with, really we wouldn't even need to mask it, right? We could just say equals 0x2. So let's test that in Node. So if we drop into Node and let's make a new, say R is equal to new uint 8 array, and it's going to be length 8. R0 equals 1. Whoops, that's not what I wanted. No, that is what I wanted. The bun REPL doesn't feel great to use. I can't put my hand on it, or I don't know why it doesn't feel great, but it doesn't. Okay, so if we do that, R should be what we want, and then we want to get a data view. So let's say dv equals new data view of our r.buffer, and then we can do data view dot get uint 8 at offset 0, and then we want to bit shift 6. Why would that? Shouldn't it be 2?
Functions.
What am I doing wrong
describe
here?
The world.
Shouldn't the value of this byte be 1, 2, 4, 8, 16, 32, 64, 64 plus 128? Shouldn't it be that? 64 plus 128. Yeah. Shouldn't that equal 192, right? Why doesn't this equal 192? Oh, each one is a byte. I'm an idiot. I'm an idiot. I'm so stupid. It's going to be 1. R at 1 is going to equal 0B 1 1 1 2 3 1 2 3. Whoops, not at 1, at 0. And then, yeah, okay, so now we go up and we do our bit shift. Where's the data get? We do it in hex. When we bit shift 6, okay, so that doesn't work. Dot toString 2. What am I doing wrong here? dv dot get uint 8 at the first spot. Oh, we never updated the data view. All right, there's that. We bit shift 6. We hit 3. Oh, that does make sense. It should be 3. Yeah. Okay. We were super close. Just got ourselves a little confused here. We'll say const is pointer. I guess we'll just get byte. That way we don't have to read twice. All right. So if it's a pointer, we need to keep track of the pointers we already hit, right? So we need like an encountered pointers state. Encountered pointers, pointer offsets, encountered pointer offsets. And this will be a number. So if we hit a pointer, we'll say if is pointer, we'll encounter pointer offsets dot push offset, and then we'll say we know the max size of a name is 255, right? So we can probably do some bit shifting here to make this extra clever rather than using an array. 200. So if we say this is a byte, we'll use it as a bit mask. Bit mask. Encountered, and we'll say this is a byte, or I guess it can be just uint 8. Zero B 1 2 3 0 0 0. Or we can just do 0x00. Type byte equals, we'll just say uint8. uint8 equals type of uint8. Dot type. And then we'll say const has encountered pointer this is going to be a little tricky here. We have the offset. We basically want to do we're going to do a like to be encountered pointers bit mask, and we would do and the offset equals the offset, right? Is that the right way to use that bit mask? Because like the idea is that, like, let's say we have 0x 0b. Let's say we hit how many is that? 1, 2, 3, 4. 1, 2, 3, 4. Let's say we hit a pointer at the second byte, right? We would set that to 1, and then we're looping back through, and we are now back at this position here. When we AND those, we get, right, we get this, and that would tell us, but like, let's say we haven't processed it for the first time, we would get this, right? And then that's not equal. Right? Yeah, I think that's right. So then we would say if has encountered pointer, we jump to the next byte, right? Because if we look at the resource record, where is that? Is it the next byte? I think it's just moving on to the next byte. Where's the compression section? Compression. So this is 2 bytes, so we need to go up 2 bytes.
The world.
So we need to do offset plus equals 2, and then we want to continue. And if we haven't seen the offset, we want to do encountered this is going to equal this with the offset. Or is it on the other side? Yeah. And that should do basically, this would do the opposite of what we just had, right? Like where we had this. When we assign with that bitwise OR, this is basically saying that, where's the OR? This becomes that, and let's say we saw it, we hit a pointer there, let's just say. Yeah, okay, that is what we want. Yeah. That feels like a pretty clever way to do that rather than using an array, because we know that the name can only ever be 255 bytes. Or is it bytes or length? Hold on, we might have to change this. I might have screwed this up. Because my coffee kind of whoops. 255 bytes or less. Labels have to be 63. Now I'm confused. We might have... What is the max length of the name field in a DNS resource record or question in max number representable by 255 bytes. It's an extremely large number. Okay, yeah, maybe we don't do a bit mask then. Although the bit mask still works, actually, right? Are we guaranteed, based on the spec, that the pointer always is the beginning of a byte? I don't know if that's true. Maybe it is. The first 2 bits. Like, what if ARPA was 1 more character long? Or foo had an extra byte? I guess it would just terminate. What would this table/datagram look like if instead of foo, it was foo? Yes. Update the full thing. What is in the offsets
Oh, 1 second.
between 30? Thank you.
You're welcome.
Are they just 0? Why does the datagram jump from offset 30 to offset 40. What does the DNS spec say would be in those offsets?
Functions describe the world.
This is the section in RFC 1030. Nice, I'm coding Cambria about name compression. Bro, I'm so confused here. So it's ignoring the other fields. I wish they put the full example here, because this is like, this makes implementing this so much harder to reason about.
Functions
For the
describe
example
the world.
in this spec, complete the full datagram without ignoring other parts, e.g. offsets 31 through 39. Thank you for the follow, Sims and Zentropy. Appreciate y'all for hanging out.
Do you know where I put, I know that's a terrible way to start this, the fob for our pool?
I have no idea, dude. I don't touch that.
I know, I messed up. Okay.
So it's not in questions. So it'll be 2 octets. 2 octets, so there's a line. There's a line. So this is 31, 32. This must be 0 padded. Yeah, this is 0 padded, right? It said that in the DNS specification. So this is the, all right, 31, 32, 33, 34, 35, 39. There it is. That makes sense. So it's going to have type, class, TTL, RD length. There we go. Just figured it out. ChatGPT died. Good job. Great job. You did so good. We're proud of you, ChatGPT. Okay, so it really is like so if we've encountered the pointer, we continue. So we hit this, we go, we need to actually what do we do here? Hold on. Actually, I wonder if we... No, that doesn't make sense. Because like once we hit the encountered pointer, we have to know how far to jump again. We need like encountered and like processed. Because between here and there is those 9 bits. That is the rest of the 9 bytes. That is the rest of the record. I mean, we could use 2. Do we have any other state that we can use to figure out if it's encountered versus processed? We can actually be even smarter here. Rather than breaking and looping back, we can just slice. So what we can do is like if we hit a pointer, we know we have to look at offset 20. So we look here, then we see that we have to read that. Or we should know... We've already read this whole name, right? We should be able to look at... We need like a mapping of... like an index of offset to name. Is that what we would want? Because we could technically slice or take a subarray we know it has to process back up to the null pointer. And we know the start of the we could figure out. Could we figure this out? We're pushing names into here. So like, let's say we have, I'm gonna have to wrap up. I don't know if I have a meeting right now. No. But I do gotta wrap. But let's just think about this. Let me write my thoughts out for this example. We have F ISI ARPA. And we hit, then we need to go back to 20. How do we know this is, how do we know that that's 20? Can we determine that this is the name that starts at offset 20? Basically, we just have to go look at this offset and we read until we hit a null 0. And then we jump back. So it'd be a great use case for algebraic effects. Maybe we just model this as a sub-read and we give it another data view. Right? We could give it a data view. Yeah, let me write that tomorrow. We'll clean this up afterwards. To do when hitting a pointer. Take a data view. So really, do we want the data view? Take a subarray of the current byte array from pointer offset to pointer offset, e.g. 20 to 44 for foo.f.sa.arpa. And then we can probably actually be smarter and drop two bytes. We could probably subtract 12. Maybe not. And then read labels until null terminating byte, and then continue processing. All right, that's what we want to do. For real, Zen. THX, before you go, can you answer what do you use for note taking? I've been trying to use Raycast notes more and more, especially now that I use the Raycast thing, but that and Apple Notes. I use Notion for like work documents, official work documents, and like during meetings, I use Granola and then copy and paste meeting notes from Granola to Notion. All right. I gotta switch over to the day job here. I think we have a good strategy tomorrow and we can just implement it, brute force it, and then clean up. And then we can get rid of that bitmask too we were using to track state. All right, let's raid Prime. All right, chat, have a kick-ass Monday, and we'll be back tomorrow.